So this video is integrated 3. It is the classwork/homework exponential and logarithmic graphs number 1. And just kind of a quick overview, I put this website up on Canvas. This is Math is Fun. And they kind of show us just a little reminder about exponential functions. If you have some base to the power x, we usually say b to the power x, but it's the same idea here. And that base has to be greater than 0. But not 1. So here you have a situation where that base is between 0 and a 1. So it's a fraction or a decimal between 0 and 1. And it's a decreasing. Because we're timesing by something smaller than 1, it's going to be getting smaller and smaller and smaller and smaller. So their example is 1/2 to the power x. This one over here is where that base is greater than 1. You can see it is increasing. Now, in both of these situations, they have an asymptote at y equals 0, which is the x-axis, okay, for both of them. They both have a y-intercept at 1, because anytime I raise anything to the power 0, I get 1. Now, this is without the graph being moved left or right or up or down or having a stretch in front of it at all, okay? And then if I am talking about logarithms, for logarithms, we have that same base a, and again, a is any value greater than 0 except 1. So when we have these two graphs, this one here is, notice it's getting smaller and smaller and smaller and smaller. This one is when my base is like a 1/2. And what's happening is my outputs are negative exponents because what's happening is, think about taking a base, grab this, let me write this real quick. Taking a base, okay, and again, we say like b, but if I have if I have 2 to the negative 1, that is equal to 1/2. If I have 2 to the negative 2, that's equal to 1/4. Okay. So what's happening here is, if I'm going out to, let's say, 2, and I'm saying, okay, 1/2 to what power gets me 2? To flip it, it's going to be a negative exponent. That's why it's a negative 1. And if I go out 1, 2, 3, 4, 2 to the 4th is 2, but 1/2 to the negative second would have been 4, and that's why I'm down here. Okay, this one here is when my base is greater than 1. Okay, so if I went out, for example, log base 2 of 1 is 0. Log base 2 of 2 is 1, because 2 to the 1st gives me 2. If I go out 1, 2, 3, 4, I'm up here at 2, because 2 to what power gets me 4? 2 to the 2nd. That's why I'm up at 2. So let me take a look at, and something else with these, they have an asymptote here at x equals 0, okay, a vertical asymptote. So now let me get back to the paper. So on number 1, this one is 2 to the power x. So the very first thing I want to pay attention to is we have an asymptote at y equals 0. So I'm going to draw that here. Okay, and again, that's y equals 0. And then if I'm doing some powers, okay, I'll kind of make a table for this, just so we understand. Let's say I'm doing -2, -1, 0, 1, 2. So 2 to the negative second is a 1/4. 2 to the negative first is a 1/2. 2 to the 0 is a 1. 2 to the first is a 2. 2 squared is a 4. So what happens here is at my 0, I have a y-intercept at 1, which is what we had talked about. Let me just get a kind of a thicker pen. So I have a y-intercept at 1. 2 to the first was 2. 2 to the second was 4. If I did 2 to the third, that's going to be 8. So that's 5, 6, 7, 8. So what you'll notice is from my asymptote, I'm 1 above. Then I double it, I'm 2 above. Then I double that 4. Then I double that 8. And if I double again, that's going to be 16. Now going backwards, I'm half and half and half. And you see here that my next one, -1, was a half, because half of 1 is a half. Half of a half is a fourth, and so on. Okay. So let me just connect this. And this is my exponential graph. Now, when I'm talking about domain and range, domain is as I go out to the left, it's going to go to negative infinity. As I go to the right, it's going to go to positive infinity. So open bracket, negative infinity to positive infinity. That's going to always be true for my domain for these exponentials. My range, there's no graph for my y's, no graph until I get to 0. And at 0, I don't have graph, but right beyond 0. So I'm going to go open bracket 0 to infinity. Okay, that is my graph. Now on number 2, 2 is log base 2 of x, which is actually the inverse of this. So what happens is this y equals 0 asymptote becomes a x equals 0 asymptote. This y-intercept of 1 becomes an x-intercept of 1. This domain of negative infinity to infinity becomes my range. And this range of 0 to infinity becomes my domain. So when I come over here, again, what I'm really looking for is I'm looking for what makes that 0. And that is going to be x equal 0. So that means I have an asymptote, a vertical asymptote on the y-axis at x equal 0. And then if I am going to kind of make a table, okay, and again, I'm going to write it out. Let's say I do log base 2 of 0, log base 2 of 1, log base 2 of 2. Let's say I do log base 2 of 4, just kind of as an example. So this first one is really saying 2 to what power gets me 0. And that is undefined. And that is why I have an asymptote here. So whatever makes this parenthesis 0, whatever makes me take log of 0, that is going to be undefined. Now log base 2 of 1, 2 to what power gets me 1? That's going to be 0. 2 to what power gets me 2? That is going to be 1. 2 to what power gets me 4? That is going to be 2. So I'm going to be plotting these. So I'm going to go out 1. Log base 2 of 1 is 0. Let me change the color. Okay, is 0. Log base 2 of 2 is 1. Log base 2 of 4 is 2. Log base 2 of 5, 6, 7, 8 would be nice. Log base 2 of 8 is 3. And then as I'm going this way, it's going to come and get closer and closer and closer to the asymptote. So let me draw that in. There you go. Now for this, my domain are x's. So as I'm coming across, I have no graph, no graph, no graph. After 0, I have graph, but not at 0. So open bracket 0 to infinity. And then my range, it goes down to negative infinity forever and ever. It's going to continue to go up to infinity forever and ever. So negative infinity to infinity. So let me just get these two to be seen together. Again, log base 2 of x and log base 2 of y equal 2 to the x and log base 2 of x are inverses. Here I have my horizontal asymptote at y equals 0. Here I have the vertical asymptote at x equals 0. My y-intercept was 1. My x-intercept is 1. My domain was negative infinity to infinity. Then now that becomes my range. My range was 0 to infinity. Now that becomes my domain. Okay, on this next one, I'm taking 1/2 to powers. So when I'm doing this, okay, what we want to remember is, and again, I can make a table. I'm just going to kind of say these as I'm doing it. The very first thing I'm going to do is I am going to plot my horizontal asymptote at y equals 0. Okay, always need to give me the asymptote. That's going to be y equals 0. And then when I'm graphing this, and I'm taking 1/2 to powers, 1/2 to the power 0 is 1. Change the color, sorry. And 1/2 to the power 1, just zoom in a little. 1/2 to the power 1 would be 1/2. Okay, I'm going to make this a little smaller as I go down. Would be 1/2. 1/2 to the power 2 would be 1/4 and 1/8 and so on. It's getting smaller and smaller. Now going the other direction, when I take 1/2 to a negative power, it's going to flip it. So a -1 is going to be a 2. 1/2 to the -2 is going to end up being 4. 1/2 to the -3 is going to end up being 8. 5, 6, 7, 8. And let me connect this. And here is our decreasing exponential graph. And my domain is going to be negative infinity to infinity, which is always my domain for these exponentials. My range is going to be from my asymptote up. So it's going to be 0 to infinity. So now I'm going to graph its inverse. Okay. So again, this is going to become x equals 0. It's going to be vertical asymptote. This is going to become my range. This is going to become my domain. This y-intercept is going to now become my x-intercept. Okay. So this is going to have an asymptote at x equals 0. And then when I'm doing this, I'm really thinking about taking log base 1/2 of 0 would be undefined. Okay. If I take log base 1/2 of 1, that's going to be 0. If I take log base 1/2 of 2, that is going to be a -1 because it's going to flip. I'm just going to move down here. If I take log base 1/2 of 4, 1/2 squared would be a 1/4. A negative in front of that would flip it. So it's a -2. And log base 1/2 of 8, again, 2 to the third is 8, but since it's 1/2, that means it's going to be a -3, so it flips it. So let me graph that. So again, as I come out 1, log base 1/2 of 1 is 0. As I come out 2, log base 1/2 of 2, -1. 3, 4, log base 1/2 of 4, -2. 5, 6, 7, 8. So log base 1/2 of 8 is a -3 and so forth. And this is going to be my graph. Now, you'll notice that this log base 1/2 of x and this log base 2 of x, are actually reflections over the x-axis, okay? So now for this, I'm gonna write in a different color since I've got a lot of stuff going on. My domain is going to be from 0 to infinity. My range is going to be from negative infinity to infinity. So now the next ones, we're going to be kind of moving them. So on this one, this graph's going to be moved to the left 3 and down 4. Okay, left 3, down 4. So left 3, down 4. And what we're looking at is that -4. That tells me my horizontal asymptote is going to be at y equal -4. So let me draw that in. Y equal -4. And then what I'm going to do is I am going to come to basically -3, -4. So -3, -4, which puts me right here. And this is kind of where I do 2 to the 0. So 2 to the 0 is 1. 2 to the first is 2. 2 to the second is 4. 2 to the third is 8. So that's 4, 5, 6, 7, 8. Next one would be 16, 32, and so forth. So let me connect this. And we have our exponential. My domain is negative infinity to infinity. My range is from my asymptote, which is at -4 up. On number 6. So when we're doing something like this, I want to ask what makes this 0? Well, what makes that 0 is a -3. So I'm going to have an asymptote at x equal -3. And so for this one, we're going left 3, down 4. And the left 3 moves my asymptote. The down 4 is going to drop the graph. So what's going to happen is, let me just grab my. So what's going to happen is as I come down to -3, -1, 2, 3, 4, here, this is where I'm going to be going out. So if I go out 1, I'm really doing just log base 2. Log base 2 of 1 is 0. Log base 2 of 2 is 1. Log base 2 of 4 is 2. Log base 2 of 8, so 5, 6, 7, 8 is 3, and so forth. So for this, I'm going to be having my graph go like this. And my domain for this is from my asymptote, which is at -3 on. My range is going to be negative infinity to infinity. Okay, so now I'm dealing with a base 3. Okay. My asymptote for this is going to be at y equal -6. So let's see. 1, 2, 3, 4, 5, 6. So I'm going to draw it here. And then if I kind of think about what makes this 0, 2, -6, I'm going to be moving to the right 2, down 6. And that's where I'm going to be starting my graph. So down 6, right 2, right here. Okay. Sorry, right here, right 2. So I'm doing base 3. So I'm going to go, okay, 3 to the 0 is 1. Let me go from here out 1. 3 to the 1 is 3. Let me go out 2. 3 squared is 9. So 3, 4, 5, 6, 7, 8, 9. And if I go out again, that's going to be 27. That's not going to fit on my graph. And here is my exponential. My domain is going to be negative infinity to infinity. My range is going to be from -6, but not including -6 up. So -6 to infinity. On number 8, this is a log, and this is base 3. So let me just jot down, if I'm thinking base 3, log base 3 of 0. Again, any log of 0 is going to be undefined. Okay, I don't care what base it is. And then if I do log base 3 of 1, that's always going to be 0. Log base 3 of 3, that's going to be 1. Log base 3 of 9, that's going to be 2. And the next one would be 27 and 81 and so forth. So on this, I'm looking at what makes this x minus 2, 0. That's going to be x equal 2. That's going to be my vertical asymptote. And then 2 comma -6 is how I'm moving. So if I go 2 and down 1, 2, 3, 4, 5, 6, right here, this is where I'm going to be going out 1 and 3 and 9. So as I go out 1, log base 3 of 1 is 0. Log base 3 of 3 is 1. 5, so 4, 5, 6, 7, 8, 9. Log base 3 of 9 is 2. Okay, and then I'm going to connect. And here's my graph. Now for this, my domain, there's no graph until I get to 2. I don't have graph at 2. I have from 2 on. My range is going to be negative infinity to positive infinity because it's going to keep going. On number 9, okay, I'm back to base 2. Now this negative, I'm not taking a negative number to a power. I'm multiplying it by a negative after the fact. Okay, so what that's going to do is instead of the graph going up like this, it's going to flip it over the x-axis. It's going to go down like this. Okay, so y equal 8. So I'm going to go up to 8. 1, 2, 3, 4, 5, 6, 7, 8. And here, this is where I'm going to have my horizontal asymptote, y equal 8. And then if I think about what makes that 0, -5, 8, that's kind of where I'm going to go. So if I go to -5, 1, 2, 3, 4, 5, -8, I'm right here. And then here I'm going to go, okay, 2 to the 0 is 1, times that by a negative, -1. And I'm going to go over 1. 2 to the 1 is 2, times that by a negative, -2. I'm going to go out 1, 2. So 2 to the second is 4, times that by a negative, -4, 1, 2, 3, 4. Next one's going to be 8. So 5, 6, 7, 8. Next one's 16. So 9, 10, 11, 12, 13, 14, 15, 16, and so on. And then I'm going to draw my graph. And again, it's flipped over the x-axis. My domain is going to be negative infinity to infinity. My range is going to be basically everything below my asymptote. So negative infinity up to 8. but not including 8. 10. So for this negative is going to flip my graph. So instead of it going like this, it's going to go like this. So it's actually going to look like a 1/2. We'll see that really is going to look like a 1/2. So I'm always asking myself, what would make this be a 0? Because I cannot take log of 0. So here, that would be a -7. So I'm going to have an asymptote at x equal -7. So 1, 2, 3, 4, 5, 6, 7. This is 7 here. I moved it over 1. Okay. And then I'm really thinking -7, 6. That's how I'm moving. So when I get my point here, I'm going to go to -7, 6. 1, 2, 3, 4, 5, 6. And here's where I'm going to go out. So if I go out 1, log base 2 of 1 is 0. I times it by the negative in front, still 0. I go out 2. Log base 2 of 2 is 1, times it by negative, I get -1. I go out 1, 2, 3, 4. Log base 2 of 4 is 2, times it by negative, I go down -2. So 5, 6, 7, 8. Log base 2 of 8 is 3, 1, 2, 3. Whoops, from here, hold on. From here. So let me count. 1, 2, 3, 4, 5, 6, 7, 8. And I'm going to go down 1, 2, 3. And if I went out 9, 10, 11, 12, 13, 14, 15, 16, log base 2 of 16 is 4, times it by negative, -1, 2, 3, 4. And here's kind of my graph. And again, you'll notice that this and my 1/2 graph, okay, are similar. This one's just shifted. Okay. And so now if I am talking about my domain, it's from -7 to infinity. My range is -infinity to infinity. Okay. So the last two have a number in front, have a stretch in front. That's really your A. That would normally be where your y-intercept is if it hadn't been moved. Okay, so now looking at this -3 means I have an asymptote at y equal -3. So let me draw that in. And then I want to kind of think about moving -4, -3. So -1, 2, 3, 4, -3. Okay. So if I did 1/2 to the power 0, that would be 1. Times it by 10, I'm going to go up 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So whatever this A is, this A times B to a power, this A is always going to be where your 0 is. That's going to be your height. Then what am I going to do? I'm going to be taking half of this. So I'm really taking half of this. So I'm going to be 1, 2, 3, 4, 5 above. Half of that, which is going to be 2.5, and half of that, which is going to be 1.25, and so on. Now, again, I could, this one here, I was kind of like my 0. 1/2 to the 0 is 1, times it by 10, I went up 10. I went over 1, 1/2 to the 1 is a half, times that by 10, half of 10 is 5. Go over 2, 1/2 to the power 2 is 1/4. Times that by 10, 10 over 4, or 2.5. But I really think about going up to my A. I'm A above my asymptote, then my B is a half. I'm going half and half and half and half and so forth. And then I'm going to connect this. And that's my graph. My domain is going to be negative infinity to infinity. My range is going to be from -3 up, but not including -3. And the last one, number 12. So this is going to be base 3. I'm asking myself what makes this 0. So that's going to be a -6. So I'm going to have an asymptote x equal -6. So 1, 2, 3, 4, 5, 6. -6, -8 is kind of where my graph's going to start. So here's -6. Then I'm going to go down 8, 1, 2, 3, 4, 5, 6, 7, 8. I'm going to go out 1. I'm doing base 3. Log base 3 of 1 is 0. I'm going to go out 3. Log base 3 of 3, 1. Okay, I'm going to go 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Log base 3 of 9, 2. Now, that's what my graph would normally be. I do have a stretch of 2 in front. So what that means, these are going to be adjusted. So let me do it in green. As I go out 1, log base 3 of 1 is 0. 0 times 2 is still 2. I mean, still 0. I apologize. Because anything times 0 is 0. So again, I go out 1, log base 3 of 1 is 0. 0 times 2 is 0. I go out 1, 2, 3, log base 3 of 3 is 1, and then I'm going to times that by 2, so I'm going to go up 2. Okay, and if I go out 4, 5, 6, 7, 8, 9, log base 3 of 9 is 2, and then I'm going to double that, so I'm going to go up 4. And then my next one's going to be 27, which isn't going to fit. So this orange was where it had been, but that stretch is changing that and make everything twice as high as it was. And then my graph is going to look like this. And my domain is going to be from -6, but not including -6 to infinity, and negative infinity to infinity. So hopefully this helps out a little bit. If you're stuck, you can always make a table.